In this video, we're going to solve logarithmic equations. And just like solving exponential equations, there's going to be two methods. One of which is kind of the clever, quick way, but you can't always use. And that's going to be when we equate logs of the same base. And what that looks like is the following. Let's say we have log base b of x, and it's equal to log base b of y. And of course, when we talk about the base of a log, it can't equal 1, and we assume that it's positive. And the same thing with x and y. We have to assume that we're taking a log of only positive numbers. Now, if this side is going to be equal to this side, it's got to be true that x and y have to be the same. And usually it will be an easy equation for us to solve. If you can't equate logs of the same base, what we're going to just simply do is write the log in exponential form. And if we do that, it should make an equation that's pretty simple to solve. So let's go ahead and do a few examples. Example 1. Let's see if we can figure out how to solve when does the log base 3 of 5x minus 1 equal the log base 3 of x plus 7. So now this looks like a scary looking equation, but if you'll notice, I have the log base 3 over here and it's equal to the log base 3 over here. If these two logs are going to be the same, it's got to be that 5x minus 1 and x plus 7 have the same value. So I'm going to just equate 5x minus 1 with x plus 7, and we're automatically in the very simple linear equation. So if we solve this, we're going to get 4x minus 1 equals 7. If you add 1 to both sides, you'll get 4x equals 8. And if you divide by 2, or excuse me, divide by 4 rather, we'll get 2. So x equals 2 appears to be the solution. Now it's a good idea to check here. If we check x equals 2 into the original, we'll have the log base 3 of 5 times 2 minus 1 equals log base 3 of 2 plus 7. So that would mean we get the log base 3, and 5 times 2 minus 1 is just going to be 9. So log base 3 of 9 equals log base 3 of 2 plus 7. That's also 9. And log base 3 of 9, by the way, is just 3 to the what power is 9. That would just be 2 equals 2. So it does in fact work. Let's do an example that's maybe a little bit more advanced than that. Let's take a look at the following. Example 2. Let's try to solve. When does 2 times the log base 3 again of 3x plus 1 equal to 4? Now here you can tell right away we're not going to be able to equate logs of the same base. There's only one log in the problem to begin with, so that first method is out the window. Okay, but what we're going to try to do to solve this is just write in exponential form. So we're going to write in exponential form. Now the key to this method, if we're going to write in exponential form, you must isolate the log. You have to get log by itself. So here in this particular problem, if you take a look, the log is not by itself quite yet. I have a 2 that's sitting out in front of it. So what I'm going to do to both sides of the equation is divide everything by 2 to start. So if I do that, these 2's will cancel, and on the left side we'll just have the log base 3 of 3x plus 1. Let's make sure to put that in parentheses so we know that 3x plus 1 is what we're taking the log of. If you divide 4 by 2, we just get 2. Now, we have the log absolutely isolated. If we write this in exponential form, you have to remember the base of the log is the base of the exponent, and what the log is equal to is the exponent for that base. So I'm going to write 3 squared equals what's inside the log, 3x plus 1. And all of a sudden we're in Algebra 1 land because 3 squared is 9, and I just have a simple linear equation to solve. Subtract 1 from both sides and you're going to get 8 equals to 3x, and if you divide by 3, we'll get 8 divided by 3 is x. So this appears to be our solution. Let's check this solution. So if we check x equals 8 over 3, we'll have 2 in front of the log of 3 times 8 over 3 plus 1, and that should be equal to 4 if you take that into the original. Now, if I simplify 3 times 8 over 3, the 3's cancel, and I get just 8 plus 1. So it's going to be 2 log of 8 plus 1, which I know is 9, and that should be equal to 4. Now, guys, oops, I forgot to write the base of log. Wasn't it log base 3? This should be log base 3 of 9, which log base 3 of 9 is just 2 because 3 squared is 9. So I have 2 times, I can replace that with 2 equals 4, and I get 4 equals 4. So that, in fact, worked. Let's make it even more challenging. Let's try example 3. Example 3. This is a good one. We have log of 5x. So it's the common log. I'm not going to write the base. Log of 5x plus the log of x minus 1, and that's equal to 2. Now, remember, in order to solve this, we need to isolate the log, and you can't isolate the log if there's 2 of them, right? So what we have to do is first condense. We have to condense first. That's a terrible looking D. Let's try that again. We have to condense first. And if you remember, when you add 2 logs, that's the product property. So I can combine these two if I use the product property by just doing the common log of 5x times x minus 1. Remember, you multiply together what's inside of the 2 logs. So really I'm taking the log of that entire product, 5x times x minus 1, and that's going to be equal to 2. So again, I just condensed using the product property. Now if I actually multiply that out and distribute, I'm going to get the log of 5x squared minus 5x inside of the log equals to 2. Now I've successfully isolated the log and I'm ready to write it in exponential form. Since it's the common log, the base is 10, and we're squaring the 10, and that should be equal to 5x squared minus 5x. 10 squared is 100, so I have 100 equal 5x squared minus 5x, and we have a nice quadratic equation to solve. Now hopefully, if you're lucky, this is one we can factor. I'm going to subtract the 100 from both sides just to set it equal to 0. Usually when we factor, we always want to use the 0 product property, right? So it's got to be set equal to 0. Now, to make factoring easier, you always factor out the greatest common factor. In this case, I'm just going to divide everything in the equation by 5. So I'll get 0 equals x squared minus x minus 20. Now I have to look for 2 numbers that multiply to make negative 20 and add to make negative 1. So that's going to be negative 5 and a positive 4, right? Those multiply to make negative 20 and they add to make negative 1. So it appears that the solutions are when x minus 5 equals 0, I'll get x is positive 5. And when x plus 4, this factor is 0, I'll get x is negative 4. Now it's a good idea to check these because maybe both of them won't work. Let's go back to the original and let's check what's happening when we plug in x is 5, and then we'll try what happens when x is negative 4. If we plug that into the original, I have the log of 5 times 5 plus the log, and I think it was what, x minus 1, so it's going to be the log of 5 minus 1 should be equal to the number 2. Well, we have the log of 25 plus the log of 4 equal to 2. And what I could do is, again, use the product property. This is going to be the log of 25 times 4 equal to 2. That's the log, I should put that in parentheses. That's the log of 100 equals 2, and I think that's right because this is like saying 10 to the what power is 100, or 10 squared is 100, and that's in fact correct. I don't think we're going to be quite so lucky if we try plugging in negative 4, and you'll see right away. If you plug in negative 4 rather, if I do 5 times negative 4 in my first log, right now, if you multiply 5 and negative 4, you're going to have to take the log of negative 20. Go ahead and try doing that in your calculator. If you try to do log of negative 20, you're going to be surprised. And that's because what you're trying to figure out here is 10 to the what power is negative 20. And guys, that's impossible. You can't raise 10 to a power to get a negative 20. As a matter of fact, you can't take the log of any negative number at all to begin with. So my hint to you is when you substitute in one of your solutions and you're taking the log of a negative number like we are here, you're going to have an extraneous solution here. So the only answer is in fact 5, and that's a little bit tricky. Let's try one more. That would be like the hardest problem that I would ever dare give you guys. And so let's see if we can do this one together. Example 4. Let's make this one a little nasty. Let's do ln of x plus 5 equals the ln of x minus 1 minus the ln of x plus 1. Well, this one appears to be nasty. Maybe it isn't. We'll see. I have ln by itself over here, and I have 2 ln's over here. And what I'm going to try to do is condense these using the quotient rule. If you remember the quotient rule, if you're subtracting 2 logs, you can do the top, x minus 1, divided by the bottom, x plus 1. You do the first guy divided by the second guy. So I've just condensed these into one log, and actually, maybe this one isn't so bad, because if you remember that first way of solving a log, if you have a log of the same base on one side and a log of the same base on the other, and these are both ln, so they're base e, you can equate the insides of the logs. So what I'm telling you is I can say, all right, x plus 5 equals x minus 1 over x plus 1. I can just get rid of those logs altogether. Now, this is a little bit weird. We never solved a rational equation, and this is maybe a little bit of a preview for next chapter. But if I want to solve this, I don't want to have this guy in the denominator, so I'm going to multiply both sides by x plus 1. So x plus 1 is what I'm going to multiply both sides by. If I do that, these will cancel, and I get x minus 1 on this side, and I have to FOIL these two binomials out. And I think if you do, you'll get x squared plus a 5x plus a 1x plus a 5. So if you add all that good stuff together, you're going to get x squared plus 6x plus 5 equals x minus 1. And notice we're playing now with the quadratic equation. I'm going to subtract x and add 1 to both sides so that I can have it set equal to 0. So I have x squared plus 5x plus 6 equals 0. And if I factor that, I think two numbers that multiply to make positive 6 and add to make 5 are 2 and 3. So I can do x plus 2 and x plus 3. My two solutions then would be x plus 2 equals 0, or x equals negative 2, and then when x plus 3 equals 0, or when x is negative 3. We always want to check though, because we might get that extraneous business. Let's try to check when x equals negative 2 and when x equals negative 3. Now right away, I know I'm going to be in trouble because take a look at, oops, I don't want to do that. Take a look at this part of the problem right here. If you just were to substitute in for ln of x minus 1, just that one log, you plug in a negative 2 there, aren't you going to get the ln of negative 3? That's impossible. You can't take the ln of negative 3 because it's a negative number. You can't raise e to some power to get negative 3. Similarly, if you were to plug in the negative 3, you're going to have the ln of negative 4, which you also cannot do. Neither one of these then, guys, work. They're both extraneous. So this is a no solution problem. It's now time for you to give it a shot. This is your self-quiz. Problem number 1, hopefully you recognize, I'm just going to give you the hint, you have two logs equal to each other and they're both of the same base, so that hopefully isn't going to be one you spend too much time working on. That should be a quick one to do, but for 2 and 3, you're going to have to make sure you get the log by itself and try to write it in exponential form. Good luck, and we'll talk about it in class tomorrow. Thanks for watching, guys.